Hi. Okay, so hi, I'm Omer. I'm a staff engineer at the Tel Aviv office of WeWork, and I just decided I want to do a talk. It was nice. But I don't have that much time, and this talk was originally 40 minutes, so I'm going to do the totally rushed edition. While preparing for it, I noticed that I had signed up for the track on my birthday, so this is the birthday edition. Yay, there's no cake, I'm sorry. So let's start with a good, something optimistic. Everything is terrible. We are human, and as humans, we make mistakes, we have errors. To err is human. We have typos, we have bugs, we have regressions, things that are ruining our days. And this is a graph I want to show. This is the cost to fix a bug over the lifetime of a system, from requirements to design and so on to operations. So two things I want you to notice here is, one, that this is a logarithmic scale. So this is logarithmically more costly over time. And the second thing I want you to notice is this is from 1981, so before I was born. So we've fixed it, right? Because unit testing is awesome. And we have a way of finding problems really early and refactoring our code with confidence. There's also, it's a good way to document the usage of our code, right? But unit testing is less awesome. It is much more code to write, and more code to review, and more code to maintain, and so much more code. There's systems where it's 6 times as much code in unit tests as it is in production code. And is it exhaustive? Really? Because 100% coverage is a lie. And it doesn't really mean that your system is actually covered by tests. It just means that you have written code that goes through all the paths in one way or the other. Tests are poor documentation. Reading code is hard. We do it every day. So writing tests, which are code, and having people read them for documentation is a pain. Another thing we have to deal with is the divergent behavior. We have documentation. Let's see, this function connects a cat to all veterinarian clinics. OK, so we have a cat ID and return the number of clinics that we've connected it to. Makes sense, right? But now the code looks kind of different. There's a cat ID, and now there's a clinic ID, and it returns a Boolean. So what does it even do? I don't know. Let's look at the tests, right? A cat may not be associated with more than one clinic. What? I am not really sure what's happening, and there's exceptions that are not documented. This is a good specimen. So what if we could have compile time annotations that enforce invariant business rules and are a good replacement for the basic validations and the tests and the documentation, and just put it there, and you can impact our code's users, and we can discover failures really early, and so on types. Right, makes sense. This is a Unconference, I think. Don't think anyone would say anything else, right? So let's take a first step. This is a type. It's connection. It accepts anything that's a host, anything that's a port. Who thinks this is a good example? Who thinks this is not a good example? Unanimous across everyone here in the room. You're wrong, because that's a maybe. It might be a good thing, because Kent Beck describes the lifetime of a system as exploring, expanding, and extracting. When you're exploring, you're actually not sure what you're even supposed to be doing. The domain has not been flushed out yet. What even is a host, man? I don't know. Why would I encode it into my code? It's going to change. I know it's going to change. There's no invariance here. When you're expanding, you have to go fast. You've gotten traction in your system. things are moving quickly. There's a lot of crashes in production, but the business is pressuring you that you have to scale up, you have to build new features, you have to do everything. There's no time to encode invariants because there are no invariants. They are still changing constantly. And then you get to growing teams, where this is a bad thing now. To extract. This is a bad thing now, and you're growing your team, and you're refactoring, you're feeling the pain, where none of your invariants are encoded into the system. So you're building new things based on shaky foundations. So let's go back to this again, and let's constrain the domain. So we have any, sure, that's awesome, but let's constrain that to any val, where we can have -2.0, that's not a good port. Let's have integers. Yes, that's a good way to represent a port, right? Nice, now we have this. But we have to have lots of documentation because it's not really constraining enough, right? I can send a -2 to the port and get an exception, right, from the constructor, because that's not a valid port. And I get an illegal argument exception. This is not fun. So can we constrain the domain even further? Can I just say valid ports, period? That means I wouldn't have to have documentation. That means I wouldn't have exceptions, right? I would just declare that I want valid ports. So I can use refine types. Who knows refine types? OK, cool. So refine types is a library where I can say things like port is an integer refined to be only in the closed interval between 0 and 64K. That means that only the types, the instances that are allowed are ones that fall into that range and are integers. So my connection class now looks like string refined to be IPv4 and a port. That's a port, right? So this would fail to compile. It's not a host. It's -1. And this would compile just fine because it fits at compile time, and the compiler checks us to make sure that we're good. But that's cheating, because we don't use literals. We use values that we get. Maybe the int, it's a port. So we use refine v, which is a macro that gives us either a string, which is the error that we got, or it gives us a port. So now we have done this explicitly. We know what failed, why it failed, when it failed, and we are proactive. We are trying to figure out what is happening before just chucking it onto the implementation and telling it, hey, tell me if anything is wrong. So refine types are here, and GitHub, whatever. They are type-level combinable predicates. So you can write things like, I want a list of integers that's refined to be both non-empty, and every single item on the list has to be positive. That's nice. So we have all these combiners. There's an entire ecosystem of libraries that have refinements for their types. So you can just add that layer on top of that and have compile time safety. There's a ton of things. I am not going to go over this slide, nor have I ever. So we've achieved something really cool. We've taken runtime exceptions and pulled them back in time in our software development lifecycle, all the way to compile time errors. We've obligated our callers explicitly to match some sort of invariant. We've documented our code because we've said, I need a port. What is a port? That's a port. So it's easier to understand, even if you don't read the documentation. And we've written less code. We don't have to write the tests to make sure that the port is a port, because those tests won't even compile on themselves. And we've done it automatically using compilers and macros. Awesome. We have an exercise to see how we can use that newfound understanding. But no, there's no time to do it. So next, interlude. What can't you statically type? You can't statically type I/O barriers. Anything outside of our type systems cannot be typed. I can't type the network. I can't type a database. I can't type a file system or the OS calls themselves, because they are fundamentally untyped. They're outside my type systems. How do I solve that? Yay. Better abstractions. Better libraries that give me better types and handle those cases in the correct fashion and share that with me through the type system as much as possible. And there are a ton of them. Another thing I want to say is that tests are never going away, ever. Sorry. So types are really good for validations, like port is a valid port number, cool. But tests are still going to be there for the more complex business rules. It means we're going to write less tests, but we're still going to write tests. Tests are good. So just in case anyone was thinking otherwise. Exercise number 2. Because we didn't have the first one, we'll have this one. So let's take our, we have a way to pet dogs, right? I send the dog ID, I pet the dog. But if I try to set a cat ID, I get a byte exception, because you don't pet cats the same way you pet dogs. So what do? OK, let's write a test. This test says cats should not be petted like dogs. Too late. Our users have already used this API. They don't care about our test. They have never read our tests. They don't care about our code at all. They have an integer. They sent an integer. OK, so what do? We can use something that's like ID types. Cool. So I have a dog ID that wraps an ID. It's a value type, so we have lower impact. And we have a dog ID in our class. We pet the dog ID, and now we just can send a cat ID into the function. That is awesome. But if I need to send any ID to something, I can't, because it's not an integer. So I would have to do dogid.id, which is annoying, right? It would make sense to make sure that the dog ID is an integer, but an integer is not a dog ID implicitly, right? So we write this. Cool. We have extract ID. It's implicit with its scope. A dog ID is now an ID implicitly. But now we have a ton more animals, and we have to write one for each of them, or complicate our domain model really, really. Another thing that's not so much fun, we can accidentally create cat IDs, right? We can just create a cat ID. I don't want that. I want cat IDs to be created by the persistence layer, right? So I mark the, oh, sorry about that. What's going on? OK. So I mark the constructor as private. Cool. But I can still accidentally create, an instance of cat ID of the cat with a dog ID, because I am unpacking the dog ID explicitly, writing it as an instance of cat ID. Not so much fun. So what can we do about that? We can use the sealed abstract trick. Who here doesn't know the sealed abstract trick? OK, cool. So sealed means I can only extend this class inside the same file, right? Only implementations inside the same file can extend this type. Abstract means I can create an instance of this without extending it. That means that the only way to create an instance of it is to write a function that creates it inside the same class, right? So what I do, I add an imply function on the companion object, and I mark its access to only be used by the persistence layer, and it creates a new instance of cat ID, an extension of the cat ID class. That's nice. I can add business logic on that. I can validate things, make sure that everything is in order. But I can't, because you can't extend a value class. So that doesn't work. OK, we've hit a dead end. So either I leave the anyval out, or I don't do this. OK, so let's look at another thing, something else, right? Let's look at tagging. So tagging is just telling the compiler, I'm adding something empty on top of this type. I'm saying this is an int with a dog ID. So this, OK, tagging. So what we do is we tell the compiler here, I know better than you, and I'm telling you that this 10 is an integer with a dog ID. So that's OK, cool, fine, you do you. But now I can use querying. I can give an int with a dog ID, and that means only types of this, and instances of this type, this tag type, can ever be accepted. So this is a nice thing because int with dog ID is still an int. So I still got the value of being able to unpack that into a primitive. There's 0 runtime overhead, and accidents are far less likely because as of is an anti-pattern in Scala. There's a convention for this. There's int at dog ID. That's tagging. Please don't roll your own. There are way too many implementations of that. Shapeless, Scala Z, and so on have their own. But this is cumbersome. So let's look at something else. There is something called new type in Haskell. And that's just, it looks like this. And it produces this. It's a macro. I don't want to go into it way too much. And it looks like a case class, right? But it's not a case class. It's actually a tag. What it is, it's a zero-cost wrapper that just adds a tag onto a type. It looks like a new type, hence, I guess, new type. It's coming in Scala 2, Scala as well. 2 is way before. As opaque types. You can read the SIP. And it's really cool. So let's look at our cases, right? We need to send an integer, right? An ID. Send me your ID. It's not an ID. So we have to work really hard to get to this point. We just change the annotation to new subtype. Now it's an int. Done. Cool. Oh, OK. So what do we do with our explicit logic and making sure nobody instantiates it like outside the scope? We can do that by just making it not a case class, just a class. And now we can do this. Easy. OK, so a recap of that, simple, is this is what it looks like now. We have a dog ID, which is a dog ID. This looks like just a case class, right? And there's 0 overhead. And unwrapping it is just referencing it. That's it. But we need to go deeper, right? Let's look at persistence. We have querying, we have deleting, and we have updating. All of those needs IDs. But creating, does it need ID? No, it doesn't need an ID. So we don't want to encode the ID into the type, because IDs are implementation detail. They're a way for our persistence layer to understand we're referencing to the correct part of the to the correct object in it. So we can separate the concerns out. We can have a final case class that's a dog with ID. So we have a dog ID, we have a dog. OK, that's cool. And then our functions look much cleaner, right? Our query just gets an ID. Our create just gets a dog. Our update gets both. And we get back what we expect. OK, let's make it generic. Awesome. Now we have a with entity and ID. So now I can just say every entity has its ID. We can couple them together. We can decouple them at will. The reason I wrote it this way is so I can use this, the infix notation, which reads nicer. It's entity with ID, right? So that's nice for everyone. And now, because we are not doing functional programming to the extreme, we're going to wrap that with a repository and have a repository of entity and ID. And we can just infer, get all the types for every function there. You can read more on this nice little blog post. OK, but we can create a repository of a dog and a cat ID. Bummer. What if we had typed connections between the dog and a dog ID, right? If I could write something like dog ID represents dog, that would be awesome, because I just wouldn't be able to create repositories with the wrong types. So what I do, I take our example, and I just tack on implicits. So now I have, an implicit. So now I have a represents type that's going to be essentially a trait that when I have an instance of it with both types, that means I have evidence that the type represents the other type. So now I have implicits. Let's fix that. So now if I have an implicit val of ID of dog, which is dog ID represents dog, now I have a typed connection between the two types, which means that I cannot create things like dog with cat ID, cat with dog ID, or dog with dog ID, then querying it for cat ID. Nice. Recap. Next. So what's the take home on this? Really simple. There's a lot to learn. It's a photo opportunity, so you're welcome to take a photo. There's a ton of kind of types in Scala, path-dependent types that we didn't go over. Blah, 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 blah. Existential types, part of it is going away, so be careful. But first, before you start using your types, do one thing. Change your build. Make it more robust. -X fatal warnings. I love it. Someone said, I don't remember who, fatal warnings is like global warming. You keep saying you need to do something about it, but you haven't, and now it's too late. So please start early. People will hate you to begin with, and then love you later. Use linters. Here's a various number of linters. There is a talk I gave about powering up your build. There's a link here. I'm going to release the slides here. It's about how to make your builds more robust. Summary, yes, we've done all of these things, and now you need to think about where you benefit. That's it. Thank you.